Hello and welcome to today's lesson. In this session, we're going to introduce the fascinating subject of chemistry and explore one of its most fundamental concepts, the atomic theory of matter. Whether you're new to chemistry or looking to deepen your understanding, this will give you a strong foundation to build on. What is chemistry? At its core, chemistry is the study of the properties and behavior of matter. Now, what exactly is matter? Matter is anything that has mass and occupies space. In other words, it's the physical material that makes up our entire universe, from the air we breathe to the stars in the sky. Although the materials around us might seem incredibly diverse, everything in our world is actually made from only about 100 elements. These elements are composed of chemically different kinds of atoms. So far, 118 elements have been discovered, but it's important to note that some of the heavier elements are short-lived and don't occur naturally. The atomic theory of matter. The idea of atoms, tiny, invisible particles that make up everything around us, has a long and fascinating history. Philosophers from ancient times were already trying to understand what the fundamental components of the world are made of. For instance, around 440 BC, the Greek philosopher Empedocles believed that all things were composed of four basic elements: earth, fire, air, and water. Similarly, ancient Hindu philosophy also included the same four elements but added space as another fundamental component of the world. However, another Greek philosopher, Democritus, 460 to 370 BC, introduced a revolutionary idea. He described the material world as being made up of tiny, indivisible particles that he called atomos, meaning indivisible or uncuttable. This was the earliest concept of what we now call atoms. But this idea didn't gain widespread acceptance right away. Plato and Aristotle argued that there could be no ultimately indivisible particles, and for many centuries, their views dominated Western thought. As a result, the atomic theory faded into the background for a long time. John Dalton and the revival of atomic theory. It wasn't until 1808, when an English scientist and school teacher named John Dalton, 1766 to 1844, revived the atomic theory with a much more precise and scientific approach. Dalton's work laid the foundation for modern chemistry, and his theory is based on four important postulates. Elements are made up of extremely small, indivisible particles called atoms. This postulate echoes the original idea from Democritus, but with scientific backing. All atoms of a given element are identical in mass and size, but atoms of one element are different from those of other elements. This means that, for example, all oxygen atoms are the same, but they differ from hydrogen atoms. Atoms of one element cannot be changed into atoms of a different element by chemical reactions. Atoms are neither created or destroyed in chemical reactions. This is the law of conservation of mass. During a chemical reaction, atoms are simply rearranged, not created or destroyed. Compounds are formed by the combination of two or more atoms of different elements in simple numerical ratios. For example, water, H2O, is made from two hydrogen atoms and one oxygen atom. Dalton's atomic model is often referred to as the golf ball model because he pictured atoms as solid, indivisible spheres, similar to tiny golf balls. The discovery of electrons. Fast forward to the late 19th century, when the concept of the atom became even more detailed. In 1891, John Stoney, 1826 to 1911, named the fundamental unit of electricity the electron, although at the time, there was no experimental evidence to support its existence. Around the mid-1800s, scientists began experimenting with electrical discharges in a nearly airless glass tube, a device invented by British chemist and physicist Sir William Crookes, 1832 to 1919. This device, known as the Crookes tube or cathode ray tube, played a pivotal role in understanding atomic structure. In these experiments, when the two electrodes in the tube were connected to a high-voltage source, the negatively charged cathode emitted a stream of invisible radiation, which was named cathode rays. Although these rays couldn't be seen directly, their presence was detected because they made gases at low pressure glow and caused other substances to fluoresce, or give off light. It was later discovered that these cathode rays could be deflected by a magnetic field and carried a negative electrical charge. While some scientists believed these rays were a type of wave, others suggested they were particles. The breakthrough came in 1897, when British scientist J. Thomson, 1856–1940, conducted further experiments using a cathode tube. He observed that cathode rays were the same regardless of the material used for the cathode or the gas inside the tube. This led Thomson to conclude that cathode rays were actually streams of negatively charged particles, the electrons. Thomson also made an important discovery about the relationship between the charge and mass of these particles. He calculated a value of 1.76 times 10 coulombs per gram, C/g, for the ratio of the electron's electrical charge to its mass. This marked a significant step in our understanding of the atom. Conclusion. So, to summarize, chemistry is the study of matter and its behavior, and matter is made up of atoms, the basic building blocks of everything in the universe. From the early theories of Democritus and Dalton, to the discovery of electrons by J. Thomson, the atomic theory of matter has evolved dramatically. As we continue to explore the structure of the atom, we move closer to understanding the fundamental forces and particles that govern our world.